Hello everyone, my project topic is wavelength octave coefficients of residuals, WOCOR, as feature extraction for speech recognition. In a paper published by Zhang et al. In 2007, they used WOCOR to do speaker segmentation. Although they concluded that WOCOR was not working as good as MFCC, it is aimed to depict the features of human vocal folds and could be a useful add-on to the MFCC features for speaker segmentation. The problem I would like to investigate is that whether WOCOR could be a potential effective feature extraction method for speech recognition. Some current useful feature extraction methods for the speech recognition are MFCC, LPCC, and LPL. They all use different approaches to obtain some features in the spectrum domain and have some good performances on speech recognition. Since the audio source I use is just the database in the Italian example, the language for speech recognition is English, which does not have phonetic intonation. In other words, no pitch information in the language. So I choose to use the fixed length audio frame as what the MFCC feature extraction does and have the hand window applied to remove high frequency noise. Then I calculate the linear predictive coefficients using the autocorrelation method. The coefficients are solved based on your WOCOR equations and Levinson-Durbin solution. Due to the time limit, I cannot go into the math details in this video, but more details could be found on the textbook. The residual signals are calculated with the LP coefficients shown on the top right corner. This should remove the contents of the actual speech and remain some voice excitation of humans' glottis and vocal folds. The next step is to calculate the wavelet transform based on the residual signals with different scaling factor A. The scaling factor A here is a parameter to control which frequency band you would like to capture for the wavelet transform. Once I get several wavelet transforms on different frequency ranges, I equally divided the transforms into M segments to remain some information in the time domain. Here is a figure that explains what each entry of the WOCOR features represents. On the y-axis, there are different frequency bands, and you can see the resolution are higher at lower frequencies. And on the bottom is a table about how many frequency bands I use in the actual implementation. Here I choose K to be 6, which means there will be 6 different frequency bands, while the paper by Zhang et al. Uses 4 frequency bands. I use 6 such that I can capture more information at lower frequencies down to about 120 Hz. Here are the results of the speech recognition with WOCOR feature extraction. You can see that the word error rate is about more than 3 times greater than the MFCC feature extraction. It does provide some help for speech recognition, but the performance is much worse than MFCC. This is kind of expected because with WOCOR, most of the spectral information of the audio is removed, and we are only doing speech recognition with the features of human vocal folds. This should not be as effective as other feature extraction methods that convey the spectral info of the audio. Thank you, everyone.